This video take a look at using the standard form of a quadratic. So the standard form of a quadratic, let me move that eraser, is when you have ax squared plus bx plus c. A, b, and c, those are those are numbers, right? So if you have a positive number at the beginning, it is what it seems like, and that parabola is going to open up. And if a is less than 0 or negative, it's a parabola that opens down. Now it's some formulas to remember. So to find the vertex, we're going to use this formula x equals negative b over 2a. Well, the b and the a, those are what are coming from your formula up here. And actually, the first thing that I would suggest using that formula for is to find the axis of symmetry. See, there's that formula, x equals negative b minus 2a. We would then plug that x into the equation, solve for y, and that'll give us a point that's the actual vertex. We'll see how that looks in just a second. So solutions are the points where if you solve your equation for y equals 0 and you solve for x, it's a little bit more involved than what we're going to get into at this point. But that's how you can find solutions using this. But the one thing that we are going to do right now in this video also is look at the y-intercept. And basically, you're going to plug in x equals 0 and then solve that thing for y. So let's take a look at one of these examples. I'm going to zoom in a little bit to give myself a little bit more space. So first off, you can see one of the suggestions I might have here, a equals 1. There's no number in front of the x squared. B equals negative 2, and then c equals 6. There's no number in front of the x squared, obviously, so that's understood to be 1, remember. So that's a positive 1, so this is going to open up. And if it opens up, right, the parabola should look like this. That means that we have a minimum at the vertex, right? That means if we had the vertex there, that's the lowest point on the graph, which means it's a minimum. Now, my suggestion, let's go find the axis of symmetry first. So we need negative b over 2a. Well, if you look above us, we just plug in those values. So we have negative, and then we plug in negative 2 over 2 times 1. Well, negative 2 is positive 2 over 2, which is 1. So the axis of symmetry is the line x equals 1. So I'm going to take a moment and draw the axis of symmetry at x equals 1. Now to find the vertex, so the vertex is going to be somewhere on this line. Well, to figure out where it goes, we need to plug 1 into our original equation. So to get the vertex, we're going to plug 1 in. So you get y equals, plug 1 in for x. 1 squared minus 2 times 1 plus 6. So 1 squared is 1, 2 times 1 is 2, plus 6. And when all is said and done, 1 minus 2 is negative 1 plus 6 is 5. So that tells me my vertex is at 1, negative 5. So let me come down here and put the point 1, negative 1, 2, 3, 4, 5. And then finally the y-intercept. What you're going to do, you're going to plug in 0 for x. So y equals 0 squared minus 2 times 0 plus 6. Well, if we look at this carefully, that disappears because we're multiplying by 0. And all we're left with is y equals 6. So the y-intercept is 6. Remember, that's where it crosses the y-axis. So let me go up to 1, 2, 3, 4, 5, 6. All right. Oh, I put that vertex in the wrong place, didn't I? That should be positive 5. Let me fix that. All of a sudden I realized 1, 2, 3, 4. My apologies with the vertex. Now, here's kind of the trick to draw this parabola. Since that red line's our axis of symmetry, that means that it's the same on both sides. We can see this point is 1 to the left of the line, which means if it's symmetric, there should be a point 1 to the right. And there it gives you the shape of that parabola, right? We already decided that it opened up, and sure enough, there it goes. Let's try one more example in this particular video. So here, a equals 3, b equals 12, and c equals 2. Since a is positive, it's going to open up. And since it opens up, right, that means that this vertex is the lowest point, which means, again, we've got a minimum. So let's find the axis of symmetry first. Negative b over 2a. So we have negative 12 over 2 times 3. So negative 12 over 6 is negative 2. So my vertex, excuse me, not vertex, axis of symmetry, x equals negative 2. So let's draw our line in at negative 2. And now let's go find the vertex. So to find the vertex, we're going to plug in negative 2. So 3 times negative 2 squared plus 12 times negative 2 plus 2. So let's start working out. Negative 2 squared will turn into negative 2 times negative 2 is 4, so we end up with 3 times 4. 12 times negative 2 is minus 24, and then we end up with plus 2. So let's keep working this thing out. So we end up with 12 minus 24 plus 2. So that's negative 12 plus 2, which will be negative 10. And it looks like, so our vertex then, we plugged in negative 2 and we got a 10. So there's our new point, negative 2, 10. We're going to have to go down a little ways. So 1, 2, 3, 4, 5, 6, 7, 8, 9. How about somewhere about right there? We're going to have to kind of guesstimate. And then we need to go ahead and find the y-intercept. Remember, this is where we're going to plug in x equals 0. So y equals 3 times 0 squared plus 12 times 0 plus 2. Let me kind of separate that word. Again, this is going to be gone because of 0. That's going to be gone. We're left with y equals 2. So my y-intercept is y equals 2. Again, if you look at that point, that's the point 0, 2. And as you can tell, that's where x equals 0. That's why when we plug in x equals 0 up here, that'll give us the y-intercept of 2. The x-intercept, or the y-intercept, excuse me, is where x equals 0. And if you do that point, you can see it. Now again, this point is currently 2 to the right of the axis of symmetry, which means there's a point 2 to the left of the axis of symmetry. And that gives us enough to draw a parabola here. It's pretty thin, long and thin, but there's your idea for the parabola there.